Hello. Welcome all the viewers in 6 day online. Just a little bit. Very good morning to all the viewers. Welcome in 6 day online lecture series for research methodology and biostatistics. Sorry for yesterday that I didn't come online, and due to any reason, I was not able to inform all the viewers. So, without any delay, we'll take the queries first, then we will proceed with two different topics which we are going to discuss today. The first one is your Mann-Whitney U test, and second one is Kruskal-Wallis test. And if time permits, I'll take one more topic called error in research. So, we have got multiple queries. Most of them I have answered through mail only, but one or two I'll take here. The first one was asked by a student from Gujarat called Forum Sethia. She was asking that the independent test require one category variable or more. See, Forum, whenever we are going to apply the independent t-test, we have to keep few things in our mind. The first one is that the dependent variable should be normally distributed, and the independent variable should be given in the form of category itself only. And category, if we are taking, that should be at least two. So in one sample t-test, what we are going to do, we are going to compare the mean of two different category. So independent variable should be given in the form of category, and dependent variable should be normally distributed. And these are the assumptions for the independent t-test. So what you have to keep in your mind while applying the independent t-test, that data of dependent variable should be normally distributed. You are going to compare the mean of two different variables, and category should be more than one. At least in there should be two different categories. And one more query we have received. They were asking that paired t-test is useful in observational study only, or it is useful in interventional studies. See, paired sample t-test can be applied for both kind of studies. Either it is your observational study or either it is your interventional study. Observational study where you are going to observe only. That means either the A is having effect on B or not. So under the A, if you have a two category, you are going to compare those category. That means what kind of response you have got before and after. For example, I have taken one example in the previous class, that pre-module and the post-module. So that can be the example of the intervention study, that where we're trying to find out that either the way of teaching is good or not. Clear? So both study can be taken under this paid sample t-test, but the things which you have to keep in your mind, that is this can be applied where you have a options called before and after, pre-module and post-module, something situation like this. That means data which you have taken is from the same population, but you have taken it two times, before and the after. So remaining queries I will answer through WhatsApp and through mail, whatever we are going to get for the today's lecture. So without any delay, I'll start my lecture. Let me share my presentation to you guys. Yes. Yeah, compare to independent non-parametric sample. If you want to compare, the test is called Mann-Whitney U. And in the last class on Saturday, we have already discussed that what were the significance and the assumptions of Mann-Whitney U. And if you are visiting first time in this channel, you can see the previous video where we have discussed that data which we are going to take for the Mann-Whitney test belongs to which type of variables. So if we want to apply the Mann-Whitney test through SPSS, there are different commands. Uh, just I'll give a little bit idea to you that how the data will be filled in the SPSS if you want to apply the Mann-Whitney U. It's a non-parametric test, and what we are going to compare here, we are going to compare the rank or the median. So median will be compared, and whatever the output sheet and the results we are going to get after applying this test, that will be the difference in the median, and we are not able to see the result like we have seen in the ANOVA post hoc test, where we are able to compare the results of A, B, and C group. So basically, the Mann-Whitney test will be called as a alternative of the independent t-test. For example, that if your data is normally distributed, you are going to apply independent t-test, and if your data is not normally distributed, you are going to apply the Mann-Whitney test to compare two different groups. So the example which I have taken, that we want to find out the waiting time of the patient, those who are visiting to a hospital in a two different department. So one department I have taken, that is your medical, and second department which I have taken, that is the clinic, for example, or the medicine. So two different department we have, and we want to find out either the waiting time is more or less in which department. So three things we are taking. Two, we have groups, that is medicine and clinic, and second one we have a dependent variable called waiting time, which is available in the form of number. So two columns we have to make in the SPSS sheet. In one column we are going to write the waiting time in minutes, or in hours, whatever is your unit of the time you are going to take for your study, that you can use. And in second column we have to give the coding to different units of the hospital. For example, to medicine we are going to keep one, and for clinic or any other department we are going to keep the code 2. So data will be entered in a special sheet for the department of hospital in the form of 121212, like that. So what was the process to apply the Mann-Whitney test in SPSS? First of all, you had to click on the analyze. Analyze is the command to whenever you are going to apply the any statistical test in SPSS. And as you know that it's a non-parametric test, because data which we have found for the dependent variable was found to be not normally distributed. That distribution is not normal for the waiting time. So we have chosen that we will apply the non-parametric test for this case, and we know that we have only two category. So for that reason we have chosen the Mann-Whitney test. So click on the independent sample. Now independent sample means here that any patient who are going to enroll in this particular model are independent to each other. That means patient number 1 does not have any correlation with the patient number 2 and the 3. So we will click on the independent sample, and whenever we will click on the independent sample, we are going to open a new window. In that window, you have to click on the under field tab. So what you have to do, whenever you are going to apply this Mann-Whitney test and the Kruskal-Wallis test, you have to customize the software. And that means directly you are not going to find a term called Mann-Whitney or the Kruskal-Wallis in direct command. So, like in chi-square, we have chosen an option with a checkbox under the cross tab, that chi-square test. Like the same here, under the independent sample, we have to click under the field, and under the field we are going to choose that we have to apply the Mann-Whitney. So there will be two options. One option will be for Mann-Whitney, and second option will be for the Kruskal-Wallis. So Kruskal-Wallis test also we are going to do today after this, and under if you will see that how to proceed. So I will show in the, see, all these steps we have to follow till 9. You can take a screenshot of this one if you want to apply that, how to apply the Mann-Whitney U. So we'll move further. We'll see in the slides that how to do it. Like this, we have to fill the data in the SPSS sheet. Like first column will be the ID of the patient. So it is not necessary. For example, this is showing that patient number 1, 2, 3, 4, and 5, and this is the independent variable. Clinic I'm going to take. So one clinic example is medical, and second one is the surgical. So only two category we are going to take for the Mann-Whitney U, and label I'm going to add. See, the same example I'm going to take for the Kruskal-Wallis test also. In that time, we are going to apply this label. So for Mann-Whitney U test, we are going to take only clinic and the time. So time which we have entered, it is available in the form of number. That means 24 minutes, 15 minutes, 14 minutes, 14 minutes, and 24 minutes. So each row is representing to a patient. That means patient number 1, patient number 2, or the sample number 1 or the sample number 2. That means patient number 1 has visited the medical ward, and waiting time was found to be 24 minutes. Patient number 2 visited to surgical ward, and waiting time was found to be 15 minutes. So now, like this, data will be filled in the SPSS for both the tests. Either it is your Mann-Whitney U or either it is your Kruskal-Wallis. So how to proceed? You can see that clinic I have divided into two different wards. One is medical, and second is your surgical unit. So just a moment, I will be sorry, sorry to interrupt. I'll just be back in a moment. Oh, sorry guys. So we are here that like this we have to fill the data in the SPSS sheet, and here you can see the example which I have taken. Clinic are divided into medical and surgical for Mann-Whitney U test, and we have taken it two categories. So if we want to apply the Kruskal-Wallis test, so there we should have a category more than two. So I have taken the example of the primary care, specialty, and the tertiary. So if you have a two category and the data was found to be not normally distributed, you can go for the Mann-Whitney U test. And if you have a category more than two and data was found not normally distributed, you can go for the Kruskal-Wallis test. Now here I will let you know one thing, that Mann-Whitney U is the alternative of independent t-test, and Kruskal-Wallis test is the alternative of ANOVA. So if you found that the data is not normally distributed and you have category more than two, you can go for test called Kruskal-Wallis. But in both the tests, I have kept the same example, which is the dependent variable is the waiting time, and data is available in the form of numbers, and here we are taking in the form of minutes. So what the hypothesis for the Mann-Whitney U test says, we have a two different hypotheses, the H naught and the HA, that is alternative hypothesis, and the null hypothesis. Null hypothesis says that there will be no statistical difference between the variables, that is independent variable. That means both the medical ward and the surgical unit have the same waiting time. Clear? So what was the aim of the test? The aim of the test is to reject the null hypothesis, and we have to prove that there is a difference in the waiting time of both the units. Either it is medical or either it is surgical. So hypothesis for Mann-Whitney test and hypothesis for the Kruskal-Wallis is the same. Just you have to increase the one number of sample in the Kruskal-Wallis. Whereas alternative hypothesis says what? That there is a statistically significance difference on the ordinal dependent variable. We can write the name that is means primary care, specialty, and the tertiary by independent variable. And here we can write the name of our independent variable, that is your three different kind of clinics and the uh, time in minutes. So what was the aim of these two tests? We have to see null hypothesis says that either we are taking 2 units or either we are going to compare the 3 units in the Kruskal-Wallis, that there is a similar waiting time in all the wards or all the units of the hospital, whereas the alternative hypothesis says at least one difference is there. Might be two sections of the hospital are having the same waiting time, but there is a difference in the one unit. So if you will get the difference in one ward or one unit, you are able to justify that there is a difference in the waiting time of all the patient. And the main objective of this test is to reject the null hypothesis that there is no difference in the waiting time. So how to do it with the SPSS, Mann-Whitney U and the Kruskal-Wallis? I'll take both together. First of all, click on the analyze. If you click on the analyze, you are going to get a option called non-parametric test. See, if you want to apply the parametric test, we are going to option called compare mean. So here we don't have to go for the non-parametric test. For non-parametric test, we are getting a direct option called non-parametric test in the SPSS. And here you can see that we have a option for one sample and we have a option for the independent sample. So for both the test, either it is your Mann-Whitney U or either it is your Kruskal-Wallis, both can be applied with the option called independent samples. Clear? So if you click on the independent sample, you are going to get a window, and for this test I'm going to use a dataset 2.3. So whenever I will going to finish the lecture series, I'm going to give this presentation as well as the dataset to all the viewers through mails, so that they can practice at home, and after taking the reference of this dataset, they will be able to find that how to enter the data for a particular test. So for this test I'm going to use a dataset 2.3. Clear? So click on analyze, click on the non-parametric test. If you click on non-parametric test, another window will open, and in that another window you have to click on the independent samples. So independent sample is the command for the Mann-Whitney U and the Kruskal-Wallis. So whenever you will click on independent sample, you are going to get a window for the non-parametric test, which have the option for the 2 or more independent sample. Here 2 is representing to Mann-Whitney U and more independent sample is representing to the Kruskal-Wallis. So you have to customize the test, that which test you want to apply, either Kruskal-Wallis or either your Mann-Whitney U. So we have to click on the field. If you want to customize the test, click on the field. If you click on the field, you are going to get this window. On the left side there you will find that we have ID, type of clinic. We have 2 units. One is your medical, second is surgical. And under the label we are not going to use for the Mann-Whitney. Label we will use for the Kruskal-Wallis, where we have a 3 different categories under the label. So I'm going to take type of clinic and the waiting time. So waiting time should be added into a test field. Waiting time should be entered into a test field, and the type of clinic should be added into a groups, because we have a 2 category under the uh, type of clinic. Clear? So type of clinic will be added into groups, and waiting time should be entered into a test field. I'll show in the slides. Uh, See, I have not taken that slide, but directly we can proceed. So after you will choose the test field and the groups, you have to click on the setting, where you are going to choose that which test you want to apply. So for that purpose, if you click on the setting, you are going to get a window which you are seeing right now, that select an item here and you have to choose the test. So click on choose test, and if you click on the choose test, this window will appear in front of you, and here you have to click on the customize test. So you have to customize the test, that which test you want to apply. For example, here you can see the option is given. One is for the Mann-Whitney U for 2 samples, and Kruskal-Wallis called one-way ANOVA for not normally distributed data, and comes under the example of a non-parametric test for k sample. Here k is representing to more than 2 sample. It can be 3, 4 or 5 also. So as you know that we are going to apply Mann-Whitney U, so we will check this box for the Mann-Whitney U test, and click run. Okay, so here you have to choose that which test you want to apply, either your Mann-Whitney U or either your Kruskal-Wallis. So just be remember one thing, that if you have only two category to compare the median, that means median you want to compare and you have only two category. So click on Mann-Whitney U, and if you have a category more than two, then you can go for a test called Kruskal-Wallis. You can click this option. So this we will take in the next test. So once you have chosen the test, you have to click on run. If you click on run, the results will appear in front of you. Now result says what? See here. Now you like parametric test, you are not going to get the descriptive statistics, and you are not going to get the post hoc table directly. Non-parametric test in the SPSS will let you know that your results was found significant or not, and if you want to compare the median, you have to choose one more option called descriptive statistics. So by using the option called descriptive statistics and frequencies, you can find out the actual median of both the group, and you can find out the difference. So what the hypothesis for this test says, whenever we have calculated the sample size for this test, the confidence interval of the study was taken 95%, and the cutoff point for this test is 0.05. And we know that here uh, the significant value uh, which we have got is 0.03, which is less than the 0.05 and less than the significance level. Here you can see that significance level is 0.05. So this 0.05 we have chosen because the confidence interval of the study which we have taken is 95%. And what was the decision for this test? We have rejected the null hypothesis. That means the median of both the units, either it is medical or either it is surgical, against the waiting time is not similar. There is a difference in the waiting time of both the wards. That means the distribution of waiting time, which is given in the form of minute, is the same across category of type of clinic. So type of clinic which you have taken to, so here it is not going to mention in the table that like previous test, that how many patient was visited under medical ward and how many patients are visited under the clinic ward. For that purpose, you have to apply the descriptive statistics by using the command called frequency. So through frequency, you can go if you want the more data for the description. But this test will suggest you directly the on the top table you are going to get by the commands which I have told you in the previous slide, like this one, that what was the significance or the p-value for the test. Either you are able to reject the null hypothesis or not. So if the p-value is less than 0.05, you are able to say that null hypothesis was rejected because the p-value which you have got is less than 0.05. So this is the result which I have obtained by using the descriptive statistics. Actually, this table you are not going to get by the command which I have told you in the previous slide. For that, you have to run a command called descriptive statistic, and after that frequency. So by using the frequency command, you are able to find the waiting time in minute and the percentile, that is interquartile range. So Different measurement of central tendency we are using to show our data in the descriptive statistics, mean. Along with that mean, we are using a standard deviation. So along with the median, we are using a percentile and the interquartile range. So this one you have to use, that is percentile 25. That means uh, IQR, interquartile range. So interquartile range means what? It means that data is divided into four equal parts by three different intervals. Now what it means, I will repeat again. The interquartile range means the data is divided into four equal parts by three different intervals. So how to explain this thing? That means we have an example of digit 100, and if you are going to divide the 100 by three different intervals, so it will be divided into 25 each, but uh, interval will be 3. So fourth one you are going to get like this only. So in each interval you are having a data of 25, 25, 25 and 25. How do you can explain this thing? That write a 100 on a paper and divide 100 into four parts, 25, 25, 25, and is scratch a line in between of each 25. So you are going to draw a three different lines. That three different lines is going to represent the three intervals. So now descriptive statistic says what? It is going to give you an idea that how many patient or samples are visited to which department and what was the waiting time. So here you can see that in medical ward, 34 patient was visited and median time was found to be 19 minutes. And in surgical ward, 46 patient visited and median was found to be 24. So there is a difference of 5 or 6 minutes in the waiting time of these two. So mean difference can be quoted in a descriptive statistics whenever you are going to write in the text. So this is the method how to write the results as per the MLA style of Mann-Whitney U test. You can write the analysis shows that the difference is significant. Here you don't have to discuss the which group and which group. Directly you can write the analysis shows that the difference is significant. In the bracket you can write p value was found to be 0.030. However, the test did not produce any descriptive table, as I told you that this table you are going to get by using different commands. Descriptive statistics, what was the command? I will let you know. First of all, you have to click on analyze, then click on descriptive statistics, then click on the frequencies. And whenever you are going to click on the frequencies, you have to click on the median, because mean you are not going to compare for the non-parametric test. You have to compare the median. So median time you are going to get and the interquartile range. So we can describe using median, but please be remember that Mann-Whitney U test is not the test for comparing the median. Actually, what we are comparing here, we are comparing here ranks. That what was the ranking order in the uh, patient or in the waiting time. So if you see my previous video, I have taken the example of A and B, and under the A I have written some observation, and under the B I have written some observation, and I told you that what we are comparing, actually what was the center point or the ranking. So Mann-Whitney U test is not only to compare the median, it is also used to compare the ranking also and the ranks. So like this you can proceed for Mann-Whitney U test with the help of SPSS. You are going to get a hypothesis test summary, and you will get the descriptive statistics using the command called median and the frequencies. So the conclusion, what we can made, you can directly write that there is a difference in the median of both the clinics. Either it is your surgical or either it is your medicine ward, and you have to compare the median waiting time for the patient, those who are attending the surgical clinic. You can write in the bracket that this much is the time, and you can write the another group also, which by which means you have compared, and you can write the timing of that group also. So whenever you are going to write the digit for the median, you have to write the units along with that. Either it is your for example, if you're going for hypertensive study, so mmHg will be written if either it is your systolic blood pressure, if it is your glucose level, that millimole per liter, if it is your BMI, then meter square, whatever the unit is there. So unit along with the digits always you should write. And what you can directly write, either the test was found significant or not significant based upon the p value which you got. So this is your Mann-Whitney U test. And if you have any queries related to Mann-Whitney U, I will be happy to answer through mail, through WhatsApp, and in the tomorrow's class. So before we start Kruskal-Wallis, I'll just give an idea that what it means. The Kruskal-Wallis test is a non-parametric test, and basically we used to call as that it is a alternative of ANOVA. In ANOVA, we are taking a dependent variable which is numerical, and in Kruskal-Wallis also we are taking a dependent variable which is numerical, and independent variable should be given in the form of category, and category should be at least more than 2. So we are going to use the same example. That means the waiting time we have to use, and in waiting time, which we have taken in the form of minutes, we are going to compare with the different labels. So instead of different wards of hospital, I'm going to include the labels. That means what kind of facility the hospital is having. For example, primary ward, tertiary ward, and the super specialty ward. So either if the patient is visiting to a hospital, they have to wait more for the primary. You can take the example of OPD, or based upon the specialty available in the hospital. So primary ward, then tertiary ward, or the super specialty. So in which ward patient have to wait more to meet a doctor, this you can find out. And by taking this example, you can compare with your branch, and you can compare this example with your studies, that if you have a two more sample to compare, and dependent variable which is given in the form of number, and that is you have found after applying the test for the normality distribution, it was found to be not normally distributed, and you have to represent your data in the form of median. Then how to proceed? So for that a particular test, uh, how to proceed, this is your Kruskal-Wallis. uh, in Kruskal-Wallis test, we used to call compare more than two independent non-parametric samples. For that purpose also, I'm going to use a data set 2.3. The same data set I'm going to use, but in that data set, instead of type of clinic, I'm going to use the labels. So example I have taken, that when we want to compare waiting time between three different units of the hospital based upon the specialty or the facility given. One is your primary care, one is your primary care, second one is your specialist, and third one is your tertiary center. That out of these three, primary, specialist, and tertiary center, either the waiting time is more in primary or specialist, or the tertiary center, in which the waiting time is more or less. This we are going to find out, and for that purpose we are going to use the Kruskal-Wallis test, which is the one way nova for the uh, not normally distributed data, clear, and equivalent for the non-parametric sample. When I have written here non-parametric sample, it means the distribution was found not normal, and we have not found the bell-shaped curve, or either the skewness was not under the range, or the kurtosis was not under the range. If I am saying range, it means whenever you are going to apply the test for the normality distribution, you are going to get the results of that test in the form of 5 different way. The first one to see the value of Kolmogorov and Shipraville. The value of Kolmogorov and Shipraville should be more than 0.05. You are going to see the QQ plot. QQ plot should be straight, and if data points are closer to a diagonal line, you can say data is normally distributed. And if you are getting a bell-shaped curve of your data, then also you can say that data is not normally distributed. And two more methods are there, which I think I have not discussed in the previous classes. That means the ranges of Skewness and Kurtosis. If the Skewness given by a software, or the ranges of Kurtosis given by the software, if it is under the ranges, you can say that data is normally distributed. And if it is less than or more than the ranges of Skewness and Kurtosis, you can say data is not normally distributed. And what are the range? Just be remember, for Skewness the ranges is -1 to +1, and for Kurtosis the range is -1.96 to +1.96. So if your data is showing Skewness or Kurtosis under or more than this ranges, you can say your data is not normally distributed and you are eligible to apply the Kruskal-Wallis test. So the steps are similar like the Mann-Whitney test, which we have done today itself only. But instead of choosing Mann-Whitney U, in the field tab or in the setting, you have to choose the option called Kruskal-Wallis test. So how to do it? These are the steps for the Kruskal-Wallis, and you can see click on analyze, then non-parametric, then independent sample is the command. Go to field tab. Under the field tab, move the waiting time into test field, and under the groups, instead of clinic, add labels, because label we are going to use for the Kruskal-Wallis. And just you have to change the step number 9. So instead of choosing Mann-Whitney U, choose here Kruskal-Wallis. Remaining all the steps are same. The two different things you have to do: instead of clinic, choose your labels, and instead of instead of Mann-Whitney U, choose the option called Kruskal-Wallis test. So how to do it? Like this, data you have to fill in the spaces sheet. ID, not that much necessary. This is the type of clinic which we have used for the Mann-Whitney U test, where we have only two different kind of categories. One category was medical and surgical. So for Mann-Whitney U test already we have used this one, so I will not use. I'm going to take only these two. One is your label and second one is the time. So time, which is a dependent variable, should be written in the form of minutes, in the form of numbers, and labels, where we have a three different categories. One is your primary, second is your specialist, and third one is the tertiary. So what we are trying to find out, we are trying to find out that out of these three different settings of the hospital, the waiting time is more or less in which group, and in which ward, or in which unit of the hospital, and we are trying to compare the median time between these three. So each row is representing to a individual sample or the patient, like this. For example, patient number 1 is visited to specialist ward and waiting time was found 24, and patient number 2 visited to specialist ward and having a waiting time of 15 minutes. So here also, for example, you can run a model where you can use the data of both these clinics as well as label. For example, under the medical, we have a three different units based upon the facilities available in the hospital, and under the surgical, again we have a three different setting in the hospital based upon the specialist. So the model can be designed in such a way that you can use the clinic as well as the label. But if you want to get results of only medical and surgical, then you have to apply Mann-Whitney U. And if you want to want to find the difference between these three, then you have to apply the Kruskal-Wallis. So like this model you have to made for your project, that this can be the one of the objective of your research that we want to find out that what was the waiting time of the hospital. So hospital is divided, for example, in the hospital, if they have a two section, you can divide that medical section and the surgical section, and under the medical, based on the super specialty, you have a three different subcategories. So this can be chosen as a subcategory. So for both purpose, you can apply these two tests. So how to do it? The example is the same. Click on analyze, click on non-parametric test. If you click on non-parametric test, you are going to get a window for the independent samples. If you click on a one independent sample, you are going to get a this non-parametric two or more independent sample window. There you have to click on the field, and in the field you have to choose waiting time again in the test field. And see here, I'm using labels instead of type of clinic, because in type of clinic we have a two units, and under the label we have a three categories. So label I'm going to add in a option called groups here. So whenever you will move the variable into test field and the groups, you have to click on the setting. So when you have finished the work under the option called field, you can move to the second option called setting, and under the setting you have to click on choose test, and under the choose test, this option will appear, and you have to click on customize the test, because here you are going to choose that which test you want to apply. In the previous test we have clicked on the Mann-Whitney U, so this time we will click on the Kruskal-Wallis, because we have a categories more than two. So I will click on the Kruskal-Wallis for one-way ANOVA non-parametric sample. We are going to compare the mean, and I will click on run. So whenever you click on the run, the results will be presented in front of you. Uh, Now result says was here. See, in the previous test we got the p-value 0.30, and here we are getting more significant results. That means there is a difference in the median waiting time of all the three uh, units of the hospital based upon the specialty or the facility given. So uh, results table suggest what? The first table will be the hypothesis test summary, and here it is going to tell you that which variable you have used for the study. That means waiting time we have compared with the option called label, and under the label we are having the three category: primary, tertiary, and the specialist, like that. So we have applied name of the test, that independent sample Kruskal-Wallis test, and we are getting a p-value. P-value here we got 0.003. So that means we are able to reject the null hypothesis. So what was the significance level of the test? Significance level of the test was 0.05, because confidence interval while calculating the sample size we have taken 95%. So against the 95% confidence interval we have got this significance level. So this will be taken as a cutoff point, and our p value or the significant value should be less than this. So here we are getting 0.05, and here we got the p value 0.003, which is very less than 0.05. So we can say that our test is passed, and we are able to reject the null hypothesis. Null hypothesis was suggesting that there is no difference in the median waiting time of all the three units of the hospital. Here, so if you want to get the descriptive statistics, like previous test, I told you that you have to run another command called descriptive analyze, then click on descriptive, then click on frequencies, and under the frequency tab you have to choose a option called median. So you are going to get a median waiting time of in minutes for all the three specialist wards, and here you are going to get a what was the waiting time of all the three wards. Here first it is representing that what was the name of the variable. Name of the variable was label, and under that label we are having a three category: primary care, specialist, and the tertiary. And under the primary we got 29 patient, and under the specialist we got 38, and under the tertiary we got 13, and this will be taken as a capital N frequencies and the count, that how many patient visited under which department. And this is the waiting time of primary care 17, and specialist is 24, and tertiary is also 24. And here you can see that waiting time for specialist and tertiary was found similar, but there is a difference in the waiting time uh, in the primary care. So might be two department will have the same what you used to call waiting time in minutes, but there is a difference in the primary care. So because of this reason, we got here value 17, you are getting a significant results. For example, here also if you have got a digit around 23, 24, or 25, in that case you will be getting a p value more than 0.05, and you will find that test was found not significant. So we are getting here digit 17, that means 17, and there is at least one difference is there. So because of one difference we are getting a significant result. So descriptive statistics for waiting time by group using median you can add in the thesis or in research paper. So no need to add a whole table in the research paper or in the thesis. Directly you can write the results in the form of MLA style, as I told you in the previous test also. You can write the result shows significant difference of waiting time between, you can write the name of all the three units, primary care, specialist, and the tertiary center, and you can write that p value was found to be 0.003. So like this you can proceed, and even you can discuss the descriptive statistics in the form of what you used to call median time of primary was found to be this much, with the help of 25% this what we used to call percentile, that is your interquartile range. So always write interquartile range with the median and standard deviation with the mean. So this is the way by which mean you can carry out the Kruskal-Wallis test with the help of SPSS. And if any viewer is having any doubt regarding the Kruskal-Wallis test, I will be happy to answer in the further classes, or they can call me, they can send the email or WhatsApp regarding their query. I will be happy to answer regarding Kruskal-Wallis or the Mann-Whitney U. And I'm going to upload both the video of Mann-Whitney U and the Kruskal-Wallis in my YouTube channel also, that is Amit Sharma. You can subscribe those channel, either ISF College of Pharmacy or my own personal channel, that is Dr. Amit Sharma. You can find in the YouTube for 4 further videos. So now we have a time, so I'll take another topics of today, that is error, because for that particular topic I have got so multiple calls as well as mails, that always you used to say that we are taking 95% of confidence interval and 5% chances of error. So what do you mean by that 5% chances of error, and what the error mean in the research? So I thought that before I proceed to other tests called linear regression, logistic regression, Ankova, Mankova, and general linear model, which are left for this series, I'll take error today. Let me see the presentation first. Yes. Uh, so, viewers, I have got, as I told you, multiple mails and messages regarding the topic called error. That viewers want to know that what do you mean by error? As I used to say several times, that confidence interval of the study we have to take 95%, and software is using the confidence interval by default as 95%, and there will be chances of error in our research always. So, what do you mean by that error, and how we are going to minimize it, and what are the method? For example, if you got a type 1 error, so what are the method by which mean we can decrease the error in our research? Yeah, so I will share my presentation to you uh, so that you it will be visible. Yes. So, topic called errors in research. Now, in this context of testing of hypothesis, there are basically two type of error. Now, as I told you in the previous classes, that whenever we are proceeding for the research, we have to make the hypothesis, and after making the hypothesis, we have to test our hypothesis. So different methods are there by which mean we can test our hypothesis, and there will be chances of error uh, in the research. So error which we are finding in the research are classified into two different types, and two different kind of error we can make. The first one we used to call type 1 error, and second we used to call type 2 error. Okay, so whenever I used to say that 5% chances of error in the research, so you can take the example that 2.5% I am keeping for type 1 and 2.5% I am keeping for the type 2. Or it can be increased or decreased based upon the hypothesis which you have made, what was the objective of your test, which kind of study design you have chosen, either you have chosen the correct formula for the sample size calculation or not. So based upon the different situations, these error can be increased or decreased. So what do you mean by the type 1 error? Type 1 error is called as error of first kind in the research. It occurs when the null hypothesis is true, but it is rejected due to unknown reason. Clear? As I told you in the previous classes also, that the whenever we will apply a statistical test, the aim of the test is to reject the null hypothesis. So error type 1 error occurs mainly when when null hypothesis is true, but you have rejected the null hypothesis due to any reason. So the rate of the type 1 error is called the size of the test. Basically, directly related to the sample size of the research, or the sample size which you have calculated for your research. So different Greek words are used. For example, here alpha is taken to represent the type 1 error, and most of the researchers are representing alpha label to represents the significance level of the test, what we used to call as a p-value. So it is denoted by the Greek letter alpha, uh, is equivalent to your type 1 error, and it usually equals the significance level of the test, as I already told you. And if uh, type 1 error is fixed at 5%, it means that there are about 5% chances in 100% that we will reject null hypothesis when null hypothesis is true. That means a confidence interval here we have taken 95%. Here I have not mentioned the word 95%, but you can assume that already I have written that if you take we are going to fix the type 1 error at 5%, so there are about 5% chances in 100% that we will reject the null hypothesis when it is true. So obviously the vice versa, we are assuming that 5% chances of error will be there, and that error will be type 1 error, and 95% of our data which we have entered, which we have collected, which we have gathered are genuine. or accurate. Whereas second type of error we used to call the type 2 error, and it is also called a error of second kind. It occurs when the null hypothesis is false, but due to error we are failed to reject it. That means null hypothesis is not true, it is false, and we have failed due to any reason. We have rejected the we are not able to reject the null hypothesis. So due to error, we will be able to fail to reject the null hypothesis. So what about type 2 error? It means accepting the hypothesis which should have been rejected. That means uh, one example I'll take for that. For example, how to differentiate both the kinds of error, that type 1 and type 2, because if you are going just words by word, it is most of the students will get confused. I'll just give a very simple example and easy to remember. For example, we have brought in house, and that house is having a facility of uh, fire alarm. Clear? What example I have taken, that we have brought in house, new house, and that house is having a facility of fire alarm. So, what is the objective of fixing that fire alarm in the house? That wherever or whenever the house caught a fire, that alarm should ring. Clear? I'll repeat again, that what was the objective of fixing that alarm, that fire alarm in the house, that whenever the house caught a fire, that alarm should ring. So two kind of error can be occurred in that example. In first example, the type 1 error means house caught a fire but alarm is not ringing due to any reason. So that kind of error will be called as a type 1 error in the research. I'll repeat again, that house caught a fire but alarm is not ringing due to any error or any reason. So that kind of error will be called as a type 1 error. Whereas false results will be given in the type 2 error. That means house has not caught any kind of fire, but whenever you are sleeping in the night, the alarm is ringing again and again. That means it will be called as a type 2 error, where the research is giving a false uh, resu- um, what word I can say, that research is giving a false reasons to justify your research. Clear? False alarm will be there in case of the type 2 error. That means house is not burning, but still the alarm is ringing again and again. You are going to fix the alarm, you will sleep, and after the 15 minute or 20 minute, the alarm will ring again. So that example can be taken for the type 2 error, or to justify both kind of error in the research, either type 1 and type 2. I'll repeat again, that with the same example, that we have fixed an alarm in a house, and the objective of that fixing alarm in the house is that whenever the house caught a fire, that alarm should ring. So in type 1 error, what has happened, that house is burning but alarm is not working, and in type 2 error, that house uh, is not burning, but alarm is ringing again and again. So false readings will be given by the alarm in second type. So in second type, you can see it will be called as a beta type of error. A type 2 error is committed when we fail to believe a truth, as I told you in the example, and the rate of the type 2 error is denoted by the Greek letter beta. So it will be represented as beta and related to the power of the test, which is equal to 1 minus beta. Here, so this table you have to see that how to see the error in the terms of null hypothesis as well as the alternative hypothesis. That means we have it made a two hypotheses. The first one is null hypothesis when it is true, and the alternative hypothesis when it is true. So we will accept the null hypothesis when it is true, so it will be called as a right decision. Clear? And one alternative hypothesis is true and we are accepting uh, null hypothesis, so it will be called as a incorrect decision, and the kind of error which will occur in the research is the type 2 error or the beta type of error. So when null hypothesis is true and we fail to accept the null hypothesis, so that time again the decision is incorrect, and it will mainly occur due to a type 1 error in the research. So by seeing this table you will be able to find out that how we can correlate our null hypothesis and the alternative hypothesis, and either we are going with the right decision or we are going with the incorrect decision due to a error, either it is your type 1 error or the type 2 error or alpha error or the beta error. So always alpha error occurs, which is the most common in the research when null hypothesis is true. Null hypothesis is true, but we will fail to accept it. Clear? And beta type of error occur when alternative hypothesis is true and we will accept that. So that kind of error is called as beta type of error. So you have to remember this table for the error. You can see the same diagram. When will you will be happy in the research, or if you're getting a type 2 error and your decision is not correct, you will feel sad. That means your null hypothesis is true, and it is, if it is accurate, and this will be denoted as 1 minus alpha, and here you are happy. Clear? When the alternative hypothesis is true and it will be failed, you are not able to accept it, that time the type of error will be type 2 error beta, and you are feeling sad. Yeah. So the same table which I have shown you in the previous slide, the same, but the mode of presentation is different, so that by seeing this icon you will be able to remember that what the table shows. So here you can see the example that I have shown the error in two different color. The first one is we have a null hypothesis, and this one HA we have a alternative hypothesis, and both type of error are representing in two different color. We have a type 1 error which is representing in the form of yellow color till from here to here, and we have a type 2 error which I have represented in this sky blue color. Now we have a center line which is I have given in pink color. This is representing to a center point. That means if I will move this pink color line to left side or right side, it is going to increase or decrease the area of either the type 1 error or type 2 error. For example, if I will move this pink line to this side, to my right hand side, so the area of the yellow side is going to increase. That means whenever the type 1 error increases, the type 2 error decreases. Vice versa, whenever the type 2 error increase in the research, the type 1 error decreases. So if one error is increasing, either it is type 1 or type 2, the another one is going to decrease. That is the vice versa of both. So by this example you can remember this, that if you are going to increase the type 1 error in the research, the type 2 is going to decrease. So the same, that what was the difference between the type 1 and type 2, this I have already taken in slide number 1 and slide number 2, but this is for the student, that most of the examiner are asking a question either for 2 marks or 5 marks, that what was the difference between the type 1 error and type 2. So type 1 error is when a statistics called the rejection of a null hypothesis which are actually true. That means we are rejecting but when it is true. And type 2 error occur when the statistics does not give enough evidence to reject a null hypothesis. That means The same example I'm taking, that A is causing B, and when we are not able to prove with the proofs that A is causing B, that time we can say that null hypothesis is actually be rejected. So this is the examples and the difference of type 1 and type 2. A type 1 error is called false positive, and a type 2 error is called false negative. It is denoted by Greek letter alpha, it is denoted by Greek letter beta, and null hypothesis and the we used to call type 1 error, and alternative hypothesis comes under the type 2 error. So like this you can say, and there are other different type of error in the research, but basically in the books or in the different research paper or review articles you are going to find these two, type 1 and type 2 only. But others are also there, like I have mentioned here, measurement error, sampling error, frame error, random error. So as the name indicates, this kind of error you can make while doing your research. But it is, for example, if you are doing a measurement error or the sampling error, it is going to affect either the type 1 or either the type 2. So chances of increasing or decreasing the type 1 error or type 2 error can occur if you are not able to uh, what we used to say, that if you are doing a measurement error, or if you are doing a sampling error or the frame error, so these kind of error can increase or decrease the chances of either type 1 or type 2. So we will just say that what you mean by measurement error, when there is a difference between the information we desire and the information provided by the researcher. That means if you are doing a error while applying the statistical test, for example, whenever you are going to compare two different variable, for example, one is your HbA1c and second one is your fasting blood sugar, both are used for the diabetic patient to know that what was the blood glucose level of the patient. So uh, one is one the unit of fasting blood sugar is uh, millimole per liter, and unit for the HbA1c is the percentage. So one, if I'm using the digit 1, so 1 is not equivalent or the same for the fasting blood sugar and for the what you will call HbA1c. You can take one more example, that normal value or normal range for fasting blood sugar is 140, whereas the normal range for HbA1c is 6.5. So 6.5 and 140 are not the equal figures. Clear? So whenever you are going to compare these kind of variable which either each other, you have to standardize the units. That means you have to tell the software that 6.5 is equivalent to 140, which is the standard ranges. That if person is having value more than this, you can say the person is diabetic. That means fasting blood sugar, if you have more than 140, you will say person is diabetic. If HbA1c value is more than 6.5, you can say the person is diabetic. So here 140 and 6.5 is not equivalent uh, to the not representing to the same digits. That means here you cannot say that 140 uh, is similar to 6.5. So you have to justify and you have to standardize both the units, that means millimole per liter by percentage. Clear? So if you are not just justifying and you are not going to standardize your units in the research, it is going to cause a type of error called measurement type of error. Now another type of error is sampling error. It occurs when a sample somehow does not represent the target population. That means I want to conduct a study on males, clear, and the data if I'm going to take from the females also. So obviously that kind of error will be the sampling error. And for example, in during the study design, if I thought that I will conduct a study on a population having age between 30 to 40 only. So if I'm taking a sample size of age 41 patient, so that kind of error we used to call a sampling error. Another one is the frame error. So frame error is representing to a area where we have thought we will conduct a study. For example, if I want to conduct a study on a Moga district, so Moga district is having a different wards. Clear? So it is necessary for me that I will take a samples from the all the wards of the Moga district. It is not necessary that if my sample size was found to be 250, so all the 250 patient I am going to take from a ward number 1 or ward number 2, and no patient from the ward number 7. So from each frame we have to calculate the sample. So whenever we are not collecting the sample from the each frame, that kind of error will be called as a frame error. So error when a sample drawn from a population differ from the target population. So when we have a target population, we have already decided while making the study design, and if you are not following that, that kind of error we used to call a frame error. And the fourth kind of error is called random error. So error because the selected sample is imperfect representation of overall population. That means you during the study you have chosen that randomly you are going to take, like in the previous example when we have conducted the Mann-Whitney test and Kruskal-Wallis, we have decided that we are going to enroll 100 patients, and we are not knowing from the beginning that which patient is going under which group. So as the patient will visit the hospital according to the his or her problem, they can go to any ward. Yeah, either they can visit the orthopedic ward, either they can visit to the dermatology ward. You are not knowing that the seventh patient who is visiting to the OPD will go to any ward. So if you have chosen the random sampling, you should follow that. And if you have chosen a particular model that the first patient should go here in group A, second patient should go into group B, so you have to follow. So if you're not following that rules which you have made during the study design, so that kind of error will be called as a random error. So different kind of error we have in research. So all these error is going to affect either the type 1 or the type 2. uh, Now main topic that how we are going to reduce the type 1 error. Clear? So uh, basically, whenever we are going to decrease the type 1 error in our research, the simple method is that we have to increase the sample size of our population until unless we are not getting the bell shaped curve. For example, you are conducting a your background is pharmacology, and you are conducting a animal testing due to on any model. So in that time, we have found that your null hypothesis was rejected due to any reason, and you are not knowing that what was the error in your research. That time what you can do, you can increase the number of sample first. For example, as per the sample size calculation, we have found that your sample size is 50. So after the 50, if you're not finding the justified result as per your hypothesis or as per your idea, in that time what you can do, you can increase the number of sample. For example, increase the 5%. If you have taken 50, you can go to 55. Again check the distribution. If it is normal, then okay. Otherwise increase little bit more till how much you have to increase, until unless you are not getting a bell shaped curve. So type 1 type of error or alpha type of error can be reduced by increasing the sample size of the study. So one option is there: increase the sample size in your study. The chances of type 1 error will be less in your project or in your research. So how to reduce the type 2 error? Type 2 error can be reduced by increasing the confidence interval of the study. For example, if you have taken a confidence interval of 95%, make it uh, 96, 97, like that, so that you will be able to reduce the chances of type 2 error. So by increasing the confidence interval of the study, you can reduce the type 1 error, and by increasing the uh, sample size of your study, you can reduce the type 1 error in your research. So other different type of error are also mentioned by some other author. If whenever I was visiting to different articles, review articles which are written on statistics or mainly on the topic called error. So they are mentioning other errors also. So what now researchers they have done, any other type of error which will not comes under type 1 or type 2, they used to call this one as a type 3. For example, frame error, measurement error, random error. Now the scientists are calling these kind of error as a type 3 error in the research. So many statisticians are now adopting a third type of error, which will be called as a type 3 error, which is where the null hypothesis was rejected for a wrong reason, and we are not able to find out that what was the wrong reason for rejecting the hypothesis. Clear? So in an experiment, a researcher might assume a hypothesis and perform the research. So after analyzing the result statistically, he found that the null hypothesis was rejected. Clear? So any kind of error which will not come under type 1 or type 2, this will be called as a now type 3 error. So already we have discussed that two basically type of error we are having in the research, that is type 1 and type 2. This will be called alpha type, this will be called beta type. And what the things you have to remember, you have to remember this table, that if your null hypothesis is true and you are accepting it, you are making a right decision. If null hypothesis is true and you are not accepting, and due to any reason you fail to accept the null hypothesis, it will be called a incorrect decision. That means you are making an alpha type of error in the research, and vice versa of that we used to call beta error. That means your alternative hypothesis is true, but you fail to sorry, you accept that, it will be called beta error. So now I will let you know that hypothesis alternative and hypothesis null means what. Basically we can take the example that we want to compare two different groups A and B. Clear? Now null hypothesis says that both the group are equivalent. That means group A and group B have the same effect. Both are equivalent. So your aim of the research is to reject the null hypothesis, and you have to prove that there is a at least one difference between A and B. Both groups are not similar. There is a difference in both the groups, and aim of the research is to reject the null hypothesis. So like this we can follow. And if you have any queries related to uh, errors, and the see I will take one more class on the topic called hypothesis, that what was the different method of uh, making the hypothesis, and how we are going to test the hypothesis in the further classes. So if you have any queries related to Mann-Whitney U, Kruskal-Wallis test through SPSS and the error, you can call me. You can subscribe my channel for more further videos. You can subscribe the channel of ISF College of Pharmacy, where you can find the live classes on the different topics. So after we will finish with the online series of biostatistics and research methodology, we are going to start another one after discussing with the management on a different subject. So meanwhile, this is all for today. Stay safe, stay home. Thanks for all.